In the quiet vastness of our cosmic neighborhood, our Milky Way galaxy isn't just drifting aimlessly. For decades, astronomers have observed a perplexing anomaly. Our entire local group of galaxies, including Andromeda and our own, is being pulled at an astonishing speed of over 2 million kilometers per hour towards a specific, unseen point in space. This mysterious cosmic force, this gravitational enigma, is known as the Great Attractor. Imagine a cosmic river, with countless galaxies as specks of dust, all flowing towards an unseen destination. That's what's happening to us. This region lies about 150 to 250 million light-years away, hidden behind the dense plane of the Milky Way, an area we call the zone of avoidance. This veil of stars, gas and dust makes it incredibly difficult to observe what lies beyond invisible light. It's like trying to see a distant mountain range through a thick fog. For a long time, we couldn't pinpoint what the Great Attractor was. Was it a single supermassive object of unimaginable scale? A black hole larger than any we'd ever conceived? Or was it something else entirely? The pull was so immense it defied our understanding of the distribution of mass in the universe. It was a cosmic ghost. Its presence felt only through its powerful gravitational influence on everything around it. Thanks to advancements in X-ray and radio astronomy, we can now peer through that galactic fog. What we've discovered is not a single entity, but something far more complex and grand. The Great Attractor is at the heart of a massive supercluster of galaxies known as the Laniakea supercluster. Laniakea, a Hawaiian name meaning immense heaven, is our cosmic home. It's a sprawling structure containing over 100,000 galaxies, all gravitationally bound and flowing towards this central point. So the Great Attractor isn't a singular object, but the gravitational center of this colossal structure. The primary source of the pull appears to be a massive galaxy cluster called the Norma cluster. This cluster alone contains thousands of galaxies, all packed together, creating an immense gravitational well that tugs on everything in its vicinity, including us. It's a breathtaking confirmation of how gravity operates on the largest scales, sculpting the very fabric of the cosmos into an intricate web of clusters and superclusters. Our journey through the universe's grand structure is guided by these unseen forces. But as we began to map this cosmic web, we stumbled upon another, even more profound mystery. If the Great Attractor is a place of immense density and matter, there exists another region in space that is its complete opposite. A place of staggering emptiness. This is the story of the Boötes Void. Discovered in 1981, the Boötes Void, sometimes called the Great Nothing, is one of the largest known voids in the universe. It's a colossal, nearly spherical region of space, almost 330 million light-years in diameter. To put that into perspective, if the Milky Way were at its center, we wouldn't have even known other galaxies existed until the 1960s. The sheer scale of this emptiness is difficult to comprehend. While our cosmic neighborhood is teeming with galaxies, the Boötes Void is eerily desolate. Initially, astronomers could only find a handful of galaxies within this immense volume. If the universe were evenly distributed, this region should contain thousands. Instead, it was almost completely empty. It was as if someone had taken a giant cosmic scoop and hollowed out a chunk of the universe. This discovery posed a major challenge to our models of cosmic evolution. According to the Big Bang Theory, the universe should be largely homogeneous on large scales. While we expect some clumpiness, galaxies, clusters, and superclusters forming along filaments of dark matter, a void of this magnitude was unexpected. How could such a vast expanse of nothingness form? The leading theory suggests that voids like boats are a natural outcome of the way the universe evolved. In the early universe, tiny quantum fluctuations were amplified by cosmic inflation. Some regions had slightly more density, others slightly less. Over billions of years, gravity did its work. The denser regions pulled in more and more matter, forming the galaxy filaments and superclusters we see today. The less dense regions, in turn, became even emptier, as the matter they once held was pulled away towards the growing cosmic structures. Think of it like making soap bubbles. The soap film forms a network of walls, and in between are large pockets of air. In the cosmos, the galaxy superclusters are the walls of the bubbles, and the voids are the empty spaces inside. The Boötes Void is simply one of the largest of these bubbles that has been discovered so far. It's a natural, albeit extreme, feature of the cosmic foam that makes up our universe. Over time, with more sensitive surveys, we have found more galaxies within the Boötes Void, about 60 so far. But this is still a tiny number for such a massive volume. These galaxies aren't randomly scattered. They seem to be arranged in a sort of tube-like structure running through the middle of the void. It's a faint, lonely filament of matter in an ocean of emptiness. These galaxies are cosmic survivors, isolated in one of the most desolate places in the universe. Together, the Great Attractor and the Boötes void paint a stunning picture of the universe's large-scale structure. They are two sides of the same cosmic coin. On one hand, we have regions of incredible density, where gravity relentlessly pulls matter together, forming magnificent superclusters like Laniakea. On the other hand, we have vast abysses of near-nothingness, testaments to the power of gravity to clear out entire regions of space. These phenomena show us that the universe is not a random scattering of stars and galaxies. It's a dynamic, evolving structure, a cosmic web of filaments, walls, and voids, all shaped by the interplay of gravity, dark matter, and dark energy over billions of years. We are not just living in a galaxy. We are part of a grand, interconnected cosmic dance. Our Milky Way is on a 14 billion-year journey, flowing along a filament of the cosmic web, pulled by the Great Attractor, and skirting the edges of immense voids like boats. As we continue to gaze into the cosmos, we uncover more of these incredible structures. Each discovery, from the pull of the Great Attractor to the silence of the Boötes void, brings us one step closer to understanding our true place in the universe. These are not just distant astronomical curiosities. They are fundamental parts of our cosmic story. A story of immense heavens and great nothings, all unfolding on a scale that both humbles and inspires. The universe is far grander and more mysterious than we could have ever imagined. And the journey to unravel its secrets is just beginning. Thank you for joining us on this exploration of the cosmos. If you enjoyed this journey, be sure to subscribe for more deep dives into the wonders of space.